So my name is Ryan Hogue. I'm a senior product manager at Opengear. In this presentation, I will be discussing how customers can leverage Opengear for their everyday workflows. So looking at who Opengear is, 18 years ago, we were founded. We created Smart Out of Band that allows pre-scripted automated actions to happen to remediate or alert or take some action that helps remediate or provide connectivity to the people that need it, to the tools and devices that they need to reach. We also have launched our Lighthouse software 10 years ago, pioneered failover to cellular, and in 2019 we joined the Digi team with a lot of the great technologies that I have that broaden both of our portfolios synergistically. We also launched our OM platforms in 2019, and just recently, right before the Tech Field Day event at Cisco Live, we launched our CM8100. We have a lot of offices worldwide, both in the US, in Europe, and as well as the Asia-Pac region. So how does Opengear solution deliver value far beyond disaster recovery? It's more than just the emergency connectivity use cases. Some people see serial console and out-of-band management. We are built on a foundation of providing resilient access during outages. Technologies like Smart Out of Band that I mentioned can perform the pre-configured automated actions, but as well as failover to cellular capabilities. However, we realize that these situations are infrequent over the course of a year. So we also serve on the first day in enabling zero-touch provisioning capabilities. This includes either DHCP relay or hosting DHCP and TFTP services on our device. Again, this may be infrequent that you have to use these, but it is helpful when you're staging equipment or bringing up branch sites. But more importantly, we like to simplify the everyday. And this is where Opengear has evolved to deliver value every day for our customers, providing an always-on secure management fabric, enabling connectivity, leveraging presence and proximity to where devices are located, and we can serve as a conduit for machine-to-machine workflows and automated tools. So Opengear can host applications, configurations, images, etc. This is why at Opengear we say we deliver value on the first day, your worst day, and every day in between, because we think that out-of-band management, when configured properly, really serves more than just a disaster recovery device. So how does Opengear deliver this everyday value? If we look at the top of our solution, we have our Lighthouse software, and this is a central management platform that aggregates all Opengear devices. Also is a searchable list of connected endpoints and provides quick access to reaching the devices needing managed, not just the Opengear appliances. There's also appliances for the small physical branches or edge locations that have 4 or 8 serial ports. And we also have larger rack-mounted appliances that are 16 through 96 ports of serial, but also with Ethernet. So when we look at our hardware portfolio a little bit more closely, you'll see we have a variety of devices that meet our customers' connectivity needs. Some are focused at the value end, providing simply connectivity for serial console is their primary focus. But we also have more advanced appliances that provide also Ethernet switching as well as cellular. Some have POTS line dial-up modems still. I know it's an old technology, but there is situations where cellular is just not an option, whether it's in the basement of an airport or some legacy colo facility that just doesn't have cellular service. So we make sure that we listen to our customers and we're providing the connectivity needs that they need to manage the infrastructure that they have. So looking at a historical and sometimes still typical out-of-band management deployment, serial console servers are separate discrete devices separated from Ethernet switches. Sometimes the out-of-band management is simply a VLAN on a production switch or a repurposed management switch that's now just some top of rack for connecting devices. When service disruption occurs in this type of a scenario, this can cut off the out-of-band network that is needed to remediate. This isn't just something that happens to small companies. It was actually a recent example of this happened at a very large social media company about a year ago. And they were unable to get to the devices they needed to remediate the situation due to a BGP and therefore DNS issue that they were not able to connect to their own domain. This is why Opengear states that device redundancy is not the same as resiliency. So how does Opengear improve this out-of-band architecture? Things that we do, we have products like the 2224E. This is a device that combines a lot of the critical connectivity that's needed, such as 24 ports of serial console, 24 ports of managed Ethernet ports with VLAN capabilities and dynamic routing, such as OSPF and BGP. It also has a mix of connectivity ports for USB, for either serial console or for mass storage of the device itself if you need to expand the storage of our device. We also have cellular for additional or redundant connectivity for that you can connect it directly into our device, not relying on your production network. And we also have 10 gig SFP uplinks on some of our devices. That's less about throughput to an out-of-band management network, but more about connectivity, such as in the core where you don't have 1 gig switch connectivity. It's nice to be able to use a breakout cable for something like a 100 gig switch and be able to step that down and connect directly without having another management switch in between. So this also collapses the number of managed devices and reduces the IT spend of both buying devices themselves on the hardware, but it also reduces spend on IT time managing devices, support contracts, warranty contracts, when you collapse them into our device. So what does this look like when you have the Opengear solution installed? We have serial console and IP device management collapsed into a single device. And we also include cellular on these products as well. So there's less devices to manage, less support contracts, as I mentioned, and added functionality. So the always-on VPN connection into the management network segment. This is especially useful for when you have VNFs that are now on server hardware. They don't have the typical serial out-of-band management serial console ports like the physical appliances had. It also gives you management of your network services. If you're running your SNMP server, DHCP, NTP, those type of things, you can access those through our device without management devices connecting to those. And what this looks like, should there be an outage, you have a cellular connectivity that now you can get into the Opengear appliances. We do have firewalls in our appliance using Firewall D based zones. We also support connecting in via VPN tunnel or IPsec into our devices. What this allows you to do is essentially connect into our device. You can connect to the other Opengear devices in the network, or you can connect into Lighthouse that gives you the connectivity, assuming you have reachability still and the disruption has not happened in between our devices and the devices needing serviced. But again, that's if your Ethernet is disrupted, you still have serial console. And that's why we say, regardless of your connectivity, you're able to reach the devices. You're not reliant on either the serial device or the IP management device. Is there any questions up to this point? If not, I'll move on.
Yeah, sorry, I had a question for you on serial connectivity.
Yeah.
And I know I've asked this before, and there never seems to be a really specific answer. How far can you take the serial connectivity, and can you extend it using fiber?
It's using fiber, typically not. That's not something I'm familiar with because it's not, unless you are going to use a media converter and actually transform that into something that could be carried over a fiber link. We're reliant on the RS-232 protocols that are looking for those connections and the data signaling and timing and hardware flow control that's built into that. Like I said, without converting that into something that would be optical, we wouldn't be able to do that. Now, if you do have longer runs beyond sort of the typical, I think it's 50 to 100 meters for serial, you can lower the baud rate, which will help. But there is an upper limit on that, and you lower it too much, and then it's almost unusable if you were to do commands that are going to either generate a lot of interaction or output that's lengthy. Also, any type of file transfer over, something like serial would be very slow. That's why we also focus on combining Ethernet in our devices. If you wanted to run a longer fiber, you could always have one of our smaller devices and use that as your media converter. So you could use your SFP port between one Opengear device and another Opengear device to provide that reachability. And then you can connect your serial locally with the smaller device at the remote end.
So, kind of adding on, and where I typically go with that line of questioning is campus. I understand putting one device in a data center, but if I've got an office building, I've got 5 floors, I've got 3 IDFs, how do I get that all together? Because it's great that I can get to my main routers and my main switches for the building, but if I'm 5 floors up and three IDFs east, I don't want to have to drive in to get serial connection on one of those, and those can be equally as important. So what's the best way to have that reach out to those campus devices, knowing that in an out of band situation, I won't be able to get to it in band? That's why there's an out of band solution.
Yeah, and thanks for your question. And obviously, every deployment is going to be unique, building by building. So we can make the recommendations like I was mentioning before that if your serial is not going to reach, it would probably be best to figure out what is the best deployment solution using Ethernet. There's new capabilities with private LTE, whether it's CBRS or upcoming 5G with slicing. If you wanted to use on a campus environment, something like one of those technologies where you have a private LTE deployment or private cellular, you could probably use that and bridge between the Opengear devices. As far as having, we agree you shouldn't need to drive in to connect serial. That's the whole point of what we're trying to eliminate, and we are quite successful in doing so. So we talk about presence and proximity, meaning we put basically the arms and legs of the network team in every rack or every row, however you want to, what your cabling looks like, to be able to, you can connect between us. We have a routed fabric. You just have to figure out how you're physically connecting the cabling between the devices or wirelessly, and essentially just use us to go between devices. Lighthouse management can take you to whatever device you need. We have port labeling that tells you what device is connected, and through something like Lighthouse, you could just search for the end device you're looking for. It will give you the ability to just click on that and open either a web CLI session or an SSH session to that device and connect directly to it from Lighthouse or from the device that has serial connectivity.
So if I'm in a campus and I've got dark fiber, I've run 24 strands, 12 pair up to a closet, and I'm utilizing, let's say, 2 or 4 pair for the actual switching. Can I grab some of that dark fiber in there and bring a device in that closet back to like a head ends an Opengear head end?
Yes, and that's why I'm talking about if you wanted to use, the fiber ports on ours. Obviously, it sounds like you have a very specific use case, and we're happy to take that offline with our sales engineers. But yes, you can use your existing fiber, connect into our SFP ports, and then have your Ethernet pass through between our devices with serial console on the other end.
Okay.
Okay, thank you for your question.
So just to make sure I understood that, it sounds like what you need to consider when you're deploying this is I need to have one of your basic devices at each physical location that I'm going to have console. So I have that whatever meter range of copper from your device to console ports. And as soon as I move to another physical IDF, I need another box there. And then the question is, am I going to use cellular or fiber or some other way to get it back to the rest of your system?
Yeah,
right?
so we're not really trying to dictate how something gets deployed. We're just saying there is physical limitations of how far you can send serial connectivity. We're
Right.
providing a mix of Ethernet, cellular, and serial connectivity with Ethernet inside of a single appliance, and allowing them to dynamically route between each other and give you the connectivity of however you architect the rest of that solution in the path.
So then the assumption is you have a really small box for those closets I have that only have like 3 devices
Yes.
in them to
Yes,
keep this from being a gargantuan budget.
Correct. And with our smaller appliances, we have devices that are either 4 or 8 serial ports, and some of them have 4 or 8 Ethernet ports as well as SFP. All of them have cellular options. They're very small, pretty affordable, about the cost of 1 truck roll to that site is your ROI on those. So we do recommend you have the Opengear presence where you have devices deployed. So getting into a little bit more technical of how this looks and what we do as far as when we talk about your routed site-to-site VPN. We're assuming an admin is outside of the corporate network now that we're working remotely, or you have remote sites. We have a VPN client installed. We have a user default gateway is in router in site 1. So typically you're going to open your VPN into the site. Your IDP is going to look at that and say that you are a out-of-band management person and you need access to those devices and sites. That validates that, and then what we end up doing is populating these routes from Lighthouse to that tunnel for that user. So now they can access this management IP network and be able to connect into Lighthouse or connect into the Opengear devices, and therefore connect into all of the devices at the different sites. You have this secure tunnel stood up from Lighthouse to our devices that's always active. It's a northbound tunnel from the appliances to Opengear. That enables engineering staff and network professionals to be able to get to the devices or leverage that VPN tunnel for other creative use cases that you may have. The other thing about this as well is if that reachability to that, into the corporate network is disrupted again, we can fail over to cellular. This can be turn on cellular only when the primary interface or your default route becomes unusable. It turns on the cellular, and now you have connectivity into that infrastructure, either via our device or if you have Lighthouse stood up in an AWS instance, an EC2 instance somewhere, or you just have it at a different site that's not affected, and you can get into that. And you still have the reachability and the connectivity across this routed VPN mesh network to get to the different sites.
How does the redundancy work for the Opengear Lighthouse server itself?
So we have a multi-instance solution currently for Lighthouse. It's not HA. It's not you don't have a virtual IP and you can connect to either one. But we do have a failover option that you can have multi-instances stood up or you could have multiple independent instances stood up as well.
And they sync their database, so they know about everything on the network.
In the multi-instance use case, yes.
All right, and I assume something like on-prem with an AWS backup is a typical scenario.
You know, I'm not exactly sure what we would consider typical. Every customer is free to deploy that, but that would be definitely one option where you would have an AWS instance on an EC2, and then you would have that either as your primary or your backup instance for your on-prem.
Could you tell us a little bit about why a cluster with a virtual IP is not an available option? What's the reasoning behind that?
It's just how it's currently built today. Obviously, we understand that that is a valuable addition to our product line, and it's something that's on our roadmap that we would be looking towards. How do we make, how do we improve our Lighthouse instance to be, potentially fully HA or, even cloud native?
Mm-hmm. And so for current deployments, is it active standby only, or is it just, can you do active, or, how does that work?
The Lighthouse is typically active standby in the multi-instance. So you're going to have sync databases, but it's going to be, you'll fail over to the secondary when your primary instance becomes unavailable. Okay.
And then my last question would be in terms of taking a look at your network here, do you have like Anycast capability? So you could send to the server that's closest. So if there's if one of the servers is closest to site 4 and 3, and the other server is closer to site 1 and 2, can you pick the more local server, or is it always designated one is active and it has to just travel regardless of distance?
Yeah, typically we're going to have a primary site until you actually issue the failover command.
Thanks very much.
Sure, thank you for the question. So I would like let's take a little bit deeper dive into this. As an example, let's look at site 3 and how this, dynamically could be routed to get there. So if we look at cellular failover, and we're going to use OSPF on, our Opengear as well as on your gateway router there. What we're looking at is you're coming in from a 172 network. You have a 10 dot, basically LAN Ethernet, and then inside of that you have your 192 out of band network and that routing is happening between your LAN and your out of band network through the Opengear device. What we're looking at is in the scenario where that would happen to fail, you no longer have a path out to the internet. Our cellular connection could either be online or come online, and this would provide you, essentially, you have your primary router using an IPSLA to track the primary path. And so when OSPF is configured to advertise the default route, when the failure is detected by the IPSLA, your OSPF updates the default route to be the Opengear over the cellular connection. So if I show the homework on that, I'm sure you're interested in what that looks like. Here's essentially what that config would look like at a high level from the OSPF point of view and the IPSLA tracking. So this failover connection is really going to be intended for carrying management traffic and other limited critical traffic like point of sale, something like that at a small site. Policies would likely need to be pre-configured to limit what traffic is permitted over a metered connection like cellular. Does
the Lighthouse have the ability to shut it off so I don't shock my cellular bill at a certain level?
Right. So I believe we do have monitoring of the data usage over cellular, and so we would make sure that, again, that's why you'd want to make sure that you have some configuration set up to say, I'm just not going to just slam all my production traffic on that network over that cellular, and you're in for a shock at the end of the month. You'd want to think about what traffic is actually permitted, or maybe only permit the certain users to be able to log in and come in through that to understand what has happened and why the default route changed. So now that we've seen some examples of connectivity and some use cases, looking at this graphic should remind you of somewhat of a layered model. And you can see at the bottom there, you start with your infrastructure physical layer. These are your managed devices, your PDUs, your switches. And what we talked about before was Opengear providing that presence and proximity. So we are the physical arms and legs for the person needing to do either their remediation or manage their workloads, workflows through our devices. You'll see that there's above that a centralized management and automation services. One could be Opengear Lighthouse, but there's a lot of other ones that you'd be running that in your development or NetOps environment or whatever it would be, and you would run that normally, but you could still pass that through our routed VPN fabric to be able to reach those devices, and you're not simply sending that over your production link. And if you make any changes that seem to have an adverse effect that was unexpected, that wasn't tested out, you can still get back in and correct those changes or roll back, roll forward to be able to do that. Above those are some applications. Our devices do support running Docker on our box. Those are either applications you can create in-house, like Matt is going to demo, or that could be something like Thousand Eyes to be able to give you some visibility into the network health of the segment that Opengear is visible to. And looking at that Thousand Eyes example, we've run this inside of Opengear. We were able to see that with the endpoint agent running on our device, you could essentially see that we had a device that went offline. We had some that the ping test did not complete. And this gives you that, again, presence and proximity. We are going to be your proxy for the network health wherever we're located and for the devices that are connected there. So in closing, again, Opengear serving the everyday, we're purpose-built to deliver reliable, resilient access. These are secure for either operators or machine-to-machine tools, and it gives you your local presence at infrastructure points and be able to connect into those, regardless if you have, you're going through normal connectivity methods or something like failover to cellular. It also separates this management access into a independent fabric for both security as well as traffic segregation. You shouldn't rely on your network to manage your network. And we consolidate the out-of-band connectivity, whether it's RS-232 or Ethernet or cellular. And the extensible environment allows for network tool teams to run, whether it's DevOps or NetOps or SecOps, whatever ops flows that your company is dealing with, you can leverage our IP fabric to help support those flows if you choose. And then doing so allows you to remove some of the shadow IT devices in your network, such as NUCs and Raspberry Pis and other things where you're going to be running small applications just for basic services that may not be in the particular location where the devices are installed.
What does your integration look like to send information from your system over to the overall monitoring systems that are out there that we're monitoring the health of the network? Are you doing streaming or anything of that nature to get this uptime data you're talking about into the main monitoring systems?
So we do, our devices are built as RESTful API at their core. So you can do API calls to get information on whether it's cellular health, network status, device connectivity, alerting, those type of things. And those APIs could be ingested into, your typical monitoring softwares.